All right, log scales help us to deal with incredibly large numbers or incredibly small numbers, and make those numbers accessible to us. So when you're dealing with a log scale type question, most of them are going to be comparing two different events or two different things and working out how much more one part of the scale is compared to another one. Okay, and it's always going to be an order of magnitude larger or smaller, so many times larger or smaller. So let's have a look at how a log scale works. The apparent brightness of a star can be found using the formula B equals 6 minus 2.5 log of A, where A is the actual brightness of that star. So to determine the apparent brightness of a star with actual brightness of 3.616, we've got that B is going to be 6 minus 2.5 log of 3.16. Now that will be put into your calculator. You want to start with the formula 6 minus 2.5 log A, and in this case B is 4.75. So the star's apparent brightness is 4.75. Okay, let's have a look at the loudness in decibels. Is related to the intensity I of the sound by the equation L is equal to 10 log base 10 of I over IO. Okay, and they've told you that IO is equal to 10 to the negative 12 watts per square meter. This is a really small number. Okay, that's like 0.0000000000001. Okay, it's a tiny number. And this value is the lowest intensity of sound that can be heard by human ears. So an ordinary conversation has a loudness of 60 decibels. Calculate the intensity in watts per square meters. Okay. Excuse me. So let's have a look. We know we've got an equation that says L is 10 log base 10 of I over IO, and we know that L in this case is 60 decibels, and we know that IO is 10 to the negative 12. So the only thing we don't know is I. Okay, so we've got 60 is equal to 10 log base 10 of I over 10 to the negative 12. And I can take that 10 to the negative 12 up, so I've got 60 is 10 log base 10 of I multiplied by 10 to the 12. Okay, and I can divide both sides here by 10, so I'll have 6 is equal to log base 10 of I times 10 to the 12. And now remembering that you can rearrange a log equation into exponential form by saying my base becomes that one's base. So 10 to the power of 6 will be I times 10 to the 12. And that means then that I will be 10 to the 6 divided by 10 to the 12, which will be 10 to the negative 6 watts per square meter. Okay, let's have a look at B. If the intensity is doubled, what is the change in the loudness correct to 2 decimal places? Now, they've given us a value, okay, but they don't necessarily have to. And I want to show you why they don't necessarily have to. Okay, if I have I2 is equal to 2 I1, okay, my first loudness is going to be 10 log base 10 of I1 over I0, and my second loudness, which is equal to 2I1, well, it's got twice the intensity, is going to be 10 log base 10 of I2 over IO. Okay. And then I want to have the difference. They're wanting the change or the difference. So I've got L2 minus L1 will be 10 log base 10 of I2 over IO minus 10 log base 10 of I1 over IO. Alright, are you starting to see that I'm going to be able to use my log laws here? So L2 minus L1. Let's put in that I2 is 2I1, so that we're only dealing with I1s and IOs. So 10 log base 10 of 2I1 over IO minus 10 log base 10 of I1 over IO. Okay. And what shall I do now? I think what I'm going to do is I'm going to split out these denominators, because I can use my log laws in an inverse form to split them out. So let's go. I've got 10 log base 10 of 2I1 minus log base 10 of IO. Okay, and then I've got minus 10 log base 10 of I1, watch your signs, minus 10 log base 10 of IO. And the cool thing here is that this 10 log base 10 of IO gets added to that log base 10 of IO. Hang on, no, that's a subtraction, that's a plus. Well, they cancel out. Cool. Okay, so we have got left 10 log base 10 of 2I1 minus 10 log base 10 of I1. Okay, and now I can put them back together again, so that I've got L2 take L1 is going to be 10 log base 10 of 2I1 over I1. Okay, and then what I can do is cancel out my I1, so L2 minus L1 will be 10 log base 10 of 2, and without having to know what I1 and I2 are, my loudness will increase by 3.01 decibels. All I'm interested in there is the difference, the change. So I guess that would have gone from 60 decibels to 63.01. But in this case here, I'm actually dealing with no numbers. So if you ever got an exam question where there were no numbers, you could actually work without them. Okay, so therefore, the loudness increases by 3.01 decibels.